Hello and welcome to Weekly Code, the weekly show where we delve into an algorithm with a new presented problem that comes in just the spirit of coding and programming, of course. This week we built an algorithm around the OEIS entry A185107, the difference of digits of nth prime. In other words, this would be a dig sub, such as a digit subtraction, where we're going to take two ones. Let's take an example. Let's take the prime number of 11. If we have 11, you would take the first digit, that is the 1, and the second digit, that is also a 1, subtract them, and that would equal 0. This would be a digit sub, or a digit subtract, or a dig sub. We're essentially going to take every prime there is, whatever we enter at least, and for every single prime, we're going to do a dig sub on it. And that's essentially what we're going to do. We, of course, have a pretty graph at the end, which is typical of every episode. As I mentioned, we'll be using the OEIS. This is the... I should click on this. But, yes, this is the OEIS entry. The Online Encyclopedia of Integer Sequences, difference of digits of nth prime. This is a commonality in this series. We occasionally use the OEIS because it's just simply very easy to find a pretty good challenge on it, if you ask me at least. First up is obviously to gather an input. Of course, I can check how this works right now, but I'm not going to. I may actually. Obviously I would, but first up is to obviously accept the input. This var we'll get to later. I probably should have named that better, but there's a certain reason that exists. I'll get to that. Num array equals bracket 1 times max num. What that does is it creates just an array of ones of the size max num. That's just a shorthand for it. Then you have temp array, which does the same thing. We'll get to what temp array is for. But the num array is the main array we'll be using. Define below 10. So for any number below 10, this is how it's going to work. We're going to do a for loop, I in range of the max num, match 1, and you have said cases. Simple. That should be easily seen because these are the first primes you get, other than 1, of course, which is already in there due to this shorthand. Now we get into the main meat, which is the up 10, which is above 10. Within the above 10, now this is going to be a recursive function I should mention. Basically, you're going to input the num array, which we have already filled up to 7, the first 5 digits. You have an iter of 5 and a record of 10. Now, every time we recurse, what the record is there for, the record is there to record the previous number for which the range should start at. At the bottom here, if I can find it, I'm not here. Here it is. So up 10, I'll get to why there's a try except there in a second, but this is -1 because we want the previous number, and that's what the record is there for. You need the +1 to make sure you're not using the previous number for the range. The max num, here's where the var comes in. You take the max num plus the num array, and you simply get your range doing this. And you simply get your range to use doing this. Now, of course, this isn't a perfect system. That's why we immediately have a break, or rather a return right here for when the num array is full. Or rather when the last digit of the num array is not changed. The var is there. The var is there because we have an if statement down here in our actual running function. I can find it again right here. Basically, that's checking if it's even or not. There's a on and off thing where if you use an odd or an even with or without the 1 or 0, then it's going to cause an error. Index loop, basically. Or rather, an over-index. I might as well get this running now, even though I haven't fully explained the problem, or I haven't fully explained the algorithm. Well, for now, we'll do 100,000. Okay. Looking at the main for loop, we're going to choose an I for every temp array. The temp array was filled with the range. We're going to iterate down. We're going to iterate down every 2, and the reason being is past 10, every 2 is past 10. You're never going to have an even number in which is prime. That's just a fact. We can look at the prime number list all day. I mean, I have it right here. We can look at it on mathisfun.org. Yeah, we can look at it. I can prove it. Yeah, it's not going to happen. Further, that's why these modalists are here. This is just checking for anything divisible by 3, 7, 5, or 2, because these are the only options when you're iterating by 2 like this, when you're skipping over the even numbers. Then of course, you're setting set I to num array if we don't skip over it with the continue mark, and you're adding to the iterator, and the loop is going to continue. Eventually, the loop does end. The loop ends because we need to refill temp array, and it continues like this in a cycle. The reason you have try except, as you probably have guessed by now, is because if we don't have try except there, Python is going to yell at us that we have recursed too much. Yeah, it is somewhat annoying. We have this simple print all function, which is simply doing this. And then we have the actual dig sub function, which is extremely simple. It's basically just an if statement asking for the I, which we have running in a for loop down here, just a dig sub on the num array, like this as such. Basically, for every number in the array, we ask if I is less than 10, then we just return the I. However, if it's not, then we're basically going to take I, divide it by 10, which just removes the 10, divide it by 10, and then subtract it from the remainder. As such. Basically, what this does is it removes the last digit, and using that number, it subtracts it from the last digit. And that's continuously how it's going to work. The reason it works is because every time you take a 5, you divide by 10, you move the decimal over one place, while every time you take a modulus by 10, that place that you just skipped over the decimal place with is simply the remainder. So, yeah, it works. It simply works, and it is a fantastic function. I quite like it. It is very nice. Of course, you have the system here, and over here, you simply have the plotting device that I used. Now, whenever this finishes, I probably should not have used 100,000. It'd be nice to have the skip. Oh. There it goes. Yeah, sorry I paused it. But, yeah, it will be done soon enough. Not much to that. In the meanwhile, we could In the meanwhile, we can look at a temporary graph on the online encyclopedia Intersequences. Pretty cool graph if I say so myself, although this is a very minute, very zoomed in on the front image. I mean, this only goes up to the 50 integers. And here's the graph we produced. Very similar. Again, it's essentially... I'm not sure. Can I zoom on this? Oh, there is a zoom button. Yeah, there we go. So we can zoom on it. It is essentially the same thing, as far as I'm concerned. So yeah, that's our pretty cool graph. I'm not sure how to zoom out on this. I'm really not. But yeah, you saw the graph. It was pretty good, pretty cool. And I think it's a pretty cool shape, at the very least. I think it's awesome, that shape. But that just about does it. Let's close that out. I think that is okay. There we go. I don't know what was going on there. But, yes, I have a Discord. I have GitHub, I have Twitter, all available to follow. I also have donation links if you appreciate this. Thanks for watching, of course.